Good morning, ladies and gentlemen. First, let us praise God for giving us guidance, happiness, health, and mercy so that we can attend and take part in this international guest lecture event without any obstacles. The Honorable Head of the Industrial Engineering Department, Diponegoro University, Dr. Purnawan Adi Wicaksono, Bachelor of Engineering, Master of Engineering. The Honorable Speaker of the International Guest Lecture, Doctor of Engineering Yasuhiro Shimazaki, as Associate Professor at the Department of Architecture and Civil Engineering, Toyohashi University of Technology, Japan. The Honorable Lecturer of the Industrial Engineering Department, Diponegoro University, and our dear participants. Ladies and gentlemen, let me introduce myself. I am Mailisa Haristi, the host of today's international guest lecture. Please allow me to read today's agenda. The schedule of this morning event is first, opening, second, head of the industrial speech by head of the industrial engineering department, Diponegoro University, third, webinar, and the last is closing. Ladies and gentlemen, let us open this event by praying according to our respective belief so this morning's event can run smoothly. Let us pray. Thank you. The next event is a speech by the head of the Industrial Engineering Department, Diponegoro University, Dr. Purnawan Adi Wicaksono, Bachelor of Engineering, Master of Engineering. Dr. Purnawan, the screen and time are yours.
Thank you, Mr. Marisa. Good morning. This is speaker, Sensei Shimasaki, all of guests, industrial engineering lecturer, and dear student. It is my pleasure to extend a warm welcome to all of you on behalf of Universitas Diponegoro, especially engineering faculty, industrial engineering department. To remark a significant moment as we gather to welcome Dr. Yasuhiro Shimazaki, a renowned expert in quantifying comfort and energy. We are honored to have Dr. Yasuhiro Shimazaki with us, whose profound insight and extensive experience in quantifying comfort and energy promise to enlighten and inspire us all. Their presence here today underscore our commitment to fostering intellectual discourse and advancing knowledge within our academic community. Events like today's guest lecture not only provide us with the opportunity to learn from distinguished scholars, but also serve as a catalyst for innovation and academic excellence. It is through such interaction that we broaden our perspective and deepen our understanding of the complexities quantifying comfort and energy. Now, I would like to express my sincere gratitude to Dr. Yasuhiro Shimazaki for graciously accepting our invitation and sharing your expertise with us. Your presence here today is a testament to your commitment to education and knowledge dissemination. Thank you very much, Sensei Shimazaki. I also extend my appreciation to the organizing committee and everyone involved in making today's event possible, especially Wiwi Budiawan and your team. Your hard work and dedication have ensured that this gathering is both meaningful and impactful. To our students, I encourage you to actively engage in today's lecture, ask questions, and seize this opportunity to expand your intellectual horizons. Let's see as the power shape your academic journey and inspire your future in the fall. Let us begin this enlightening session with quantifying comfort and energy. I am confident that today's discourse will enriching and thought-provoking.
Itu
Finally,
sebagian bukan
for present here today. Thank you very much for all of you.
Thank you for the opening speech, Dr. Ladies and gentlemen, this is the main event we have been waiting for. The International Guest Lecture with Doctor of Engineering, Yasuhiro Shimazaki as Associate Professor of the Department of Architecture and Civil Engineering at Toyohashi University of Technology, Japan. The topic that will be presented is quantifying comfort and energy. Today's event will be moderated by Dr. Wiwi Budiawan. He is an assistant professor at the Industrial Engineering Department at Diponegoro University. The time and screen are yours.
Okay, thank you very much, Miss Melissa. Good morning, everyone. Let me introduce myself. My name is Wi Budiawan, and it's my great pleasure to welcome you all to the International Guest Lecture on the quantifying comfort and energy. We are also honored to have the distinguished guests and also expert with us who will share their insight and knowledge on this maybe interesting topic and also crucial topic today. So if I want to give the action that this event aims to explore the intersection between comfort and also the energy. So this topic that is increasingly significantly until today, and also our effort to create the sustainable and livable environment. Today's lecture will delve into the methods and also technology comfort levels and also the energy efficiency. And this is also like the continuous activity or agenda from the our department in industrial engineering. For your information, for the participant in this year, we also send our student to the Toyohashi University of Technology under supervise the Shimazaki Sensei and also the team in the Toyohashi University of Technology. So I will show you the profile of our guest lecturer today. So please, Mr. Aldo. So before I would like to introduce our esteemed speaker. The name is Dr. Yasuhiro Shimazaki. Okay. So Dr. Shimazaki is a distinguished expert in the field of environmental comfort and energy efficiency with a particular focus on ergonomics and also application in some industrial section or area. So Dr. Shimazaki on the PhD in environmental we cannot mention here only the Osaka Prefecture University, and also the research interest in environmental engineering, clothing science, ergonomics, thermophysical property, and also the other thermal comfort. And also over the years, some published or I think we can throw to the down in the okay. So some the committee membership and also the awards from the Dr. Shimazaki. So the committee membership is the environmental impact assessment, and also in here is review committee members in Hamamatsu City, and also consider Japan society thermophysical properties from 2021 until 2023, and the executive committee, the member of Comfort and Smart Symposium 2019, the Japan Research Association for Textile and use from the 2019 and 2019. Some awards that get from the Dr. Shimazaki in the March 2024, the Excellent Poster Awards, and 2017, the 32nd Japan Road Conference Excellent Paper Awards, and also the same year with the Excellent Paper Award in the 4th International Symposium on Asphalt, Pavement and Environment, and so on. I will give you the link from the Dr. Shimazaki. If you have any interest or same related topic, I think we can discuss in this event or this guest international lecture. Okay. For the introduction, I think it's enough. From here, I will give you agenda today, Sensei. So you can give the presentation for the maximum 45 minutes.
Okay.
And then we follow by the question and answer during maybe 30 minutes, where the participant can ask directly in the open mic, and also you can text in the chat box. So we will provide your question, and we'll give the chance to the Shimazaki Sensei or Dr. Shimazaki to answer this question. Okay. Okay, time and media is yours, Sensei.
Okay. Can you see the slide?
Okay, clear and bright.
Okay. So let's start. So hello everyone. And there's a 2-hour time difference between Japan and Indonesia, so maybe it's a good morning to all. I'm Yasuhiro Shimazaki at the Toyohashi University of Technology in Japan. I'd like to thank for the opportunity to give the presentation today. Today's topic is quantifying the comfort and the energy in buildings. So what are we quantifying for? It is for the designing for the good architecture. So this slide, this is the outline of today's lecture. The first of all, I want to give a very simple self-introduction. Dr. Vivek already done my introduction, but I like to give some very small introduction by myself. And then I want to talk to you about creating comfort and energy in a building. Then after this lecture, I hope you can become able to understand situation facing international community in building. And also, I hope you can recognize challenges that we make based on the knowledge from building science, especially for the comfortable, energy efficient designing for architecture. Okay, so first part is the self-introduction. Actually, it's quite natural that you may think, who am I? Yeah, I'm a doctor of engineer. I received a PhD from Osaka Prefecture University in 2010. And now I'm an associate professor working for the Department of Architecture and Civil Engineering at the Toyohashi University of Technology. Because my primary interest is the human itself, my research mainly focuses on the living environment. I'm currently investigating comfort designing from various aspects, such as thermal, acoustic, and material, like clothing, and so on, focusing on the effect of the urban and the building components with using both field measurement and also the numerical simulation. we do both for the measurement and also the simulation. Next, I'd like to introduce our university at TUT. Some students and some professionals may know the name TUT because we have the agreement, MOU agreement between us. TUT was established about 50 years ago as a research university by the Japanese government. And so the mission of the TUT is to conduct the research and education in technological science and developing new technology through the scientific inquiry. TUT, one of the global focused university, and the TUT and we promote the joint international research and also the personal exchanges. Actually, about 50 to 20% of the students comes from overseas. We can see so many Indonesian students here. I hope this could be a nice opportunity for the collaborative study this time. Okay, so let's go to the next. Today's topic is about the architecture and the building. Some students are not familiar with today's theme, the architecture. So in this slide, I show you some example of Japanese architecture. So what do you think the good architecture is? Either looking good or the comfortably usable? I think it depends on you, but yeah, I'd like to introduce the first picture here is the Japanese National Olympic Stadium in Tokyo, designed by the Kengo Kuma. This is for the 2020 Tokyo Olympic Game Stadium. It is wood and green stadium, you can see here, and featuring Japanese climate, the culture and tradition, gently blended the architecture with its green environment. Actually, this stadium is surrounded by the trees and some forest of the shrine. Okay. The second picture, this one, shows the Mizunami Kita Junior High School in Gifu Prefecture. This building is Japan's first ZEP school building, the energy efficient school building in Japan. And you can see here, the last picture shows the Japanese traditional tsuboniwa court garden. I think that you may see this kind of courtyard in the manga or cartoon. It's warm if it's sunlight shine during the winter season, and it's cool if wind blows during the summer season. The phrase that the good architecture is typically a very subjective phrase. The good design or the good architecture can serve a much higher purposes than just simply nice to look at. So we try to figure out exactly how to quantify the value of the good design in this lecture from my viewpoint. Okay, here you can see this slide. Architecture department in Japan is mainly consists of 3 academic areas in a Japanese university to foster good architects. To research need to draw up the concept for the kind of architecture to be built and compile the basic plan. This knowledge for the planning and designing drawing is, of course, fundamentally important. The buildings are, of course, subject to laws and to the forces of such as the earthquake, the wind, So the architect must be stand up to these forces while staying safe. The knowledge for the dynamics or the technology for structures and the material we use is, of course, important. And here, the architecture is for the occupant from my viewpoint, and so that we need to look into how we can create the comfortable space by planning and designing. Also, as it requires the consideration of the physiology, human physiology, and the human psychology of the occupant and the global environment. The environment topic is more and more common in architecture. In this lecture, we are focusing on the architecture environmental area here. So to summarize, the building science in this lecture is a field of the study concerned with the technical performance of the building material, and the building systems. Of course, building science is broad enough to include the construction technology, material science, and the urban designing, the architecture, physics like heat and mass transfer, and also the methodology or the climatic, the knowledge, and so on. And the building science is gathering attention because the issue of the sustainability, pollution, energy use, and occupant health are becoming increasingly important. The building science is a broad term that refers to our knowledge of the physical behavior of the building, the heat, light, and the sound, air quality, and their impact on energy efficiency, comfortable, health, safety, durability, and so on. And it is application of the to the built environment. The building services is also our field. Building services are the system installed in the buildings to make them the functional, the efficient, and safe. So based on the knowledge of the building science, we should install the building service for the comfort and the energy and so on. Okay, so in the environmental engineering in the architecture, we explore the design and the systems and in building and to effective use of the energy and material. And I have to emphasize that the importance mission or from our study field is to provide a comfort in the building with minimum energy use. Okay, so the motivation and objective in this study field is to balance the comfortable life and energy saving for the architecture and the urban designing passively. Okay, and to gain the comprehensive understanding of the outer building indoor environment for the better futures. This slide shows the conceptual relationship between comfort and energy. In general, the outdoor climate fluctuates largely. In Japan, we experience the cold winter and also the hot, humid summer. So they fluctuate like this, the green line. The engineer out climate they fluctuate largely on a daily basis, day and night, and or the yearly basis, the winter and the summer. On the other hand, the comfortable range, nearly the red dot line, is relatively narrow compared to the climatic changes like the green line. So in order to achieve the comfortable level, we have two ways. One is passive solution. The other one is active solution. The passive solution or passive technology, or the active solution, or the active technology. A passive solution use the architecture mean without the energy. And the active solution use the equipment or the services such as AC, fans, and so on, and of course use energy. So in this sense, we utilize the passive solution first, then minimize the use of active solutions. Totally combining both the active method and the passive method for the thermal comfort, leading reduction in energy consumption. Okay, so let's move to the main topic here. This shows the primary energy consumption by country in 2021. You can see the the first place for the energy consumption is China, and the second place is the US. Japan is fifth place. So what do you think Indonesia's rank is? Maybe 20, 30. The Indonesia is the 12th place. Indonesia is the 12th largest energy user globally. How do you think about that? Some professors are laughing. It's quite interesting. Yeah, because Indonesia has a larger population, they use energy, of course. Yeah, there is a well-known fact that the building is the world's greatest energy user. You can see the graph here. This is the case for the US. You can see the breakdown of the energy consumption in the USA. The energy consumption in industry is decreasing, but it's about 1/3 of the energy consumed by the industry. On the other hand, energy used in building is increasing. And about 40% of the energy is used inside the buildings. Most of the energy used in a building is used to maintain a comfortable indoor environment. In terms of the thermal comfort, you can see that both for the residential and the commercial building, the cooling and heating has a larger impact on energy use. And also the ventilation requires some energy. The other energy use other than cooling and heating, and of course the lighting, hot water supply, and household appliances, and the electric equipment. For me, actually, this is quite reasonable, and there is no big difference between the industrialized country. I see some data for the Indonesian situation. The transportation is the largest energy user in Indonesia. So the situation is a bit different from the US and Japan. More and more energy is now the use in transportation in your country. Yeah. And this graph shows the annual energy consumption in the household in Japan. And similar to the US in the previous slide, the daily operation use most of the energy, and more than 50% consumed by the heat source, such as the heating, the cooling, and the hot water supply. The energy use is correlated with the temperature difference and the period of use. So normally, the heating energy is much larger than the cooling in northern hemisphere like US and Japan situation. Of course, Japan is a large country from north to south, So the situation is quite different in Hokkaido and Okinawa, but in averagely, the energy used for the heating is quite larger compared to the cooling. Actually, we have a tradition to take a bath. So in Japan, we use energy for the hot water. This is one of the features for the Japanese situation. Okay, to summarize, yes, of course, the building have a significant impact on the natural environment, the human health and comfort, and energy consumption. But we did not say that just endure without the energy. So we have to utilize the passive solution. The important mission to provide the comfort in building with minimum energy use. Again, so the behavior, the modification, and the deep understanding of the architecture mean is required. Because this is just one example. In Japan, the air conditioning setting for summer is over the world. When I went to the Jakarta, the temperature setting for the AC in a hotel is quite low for me. I feel like the too chilly at about 16, 18 degrees Celsius. It's normal. So the deep understanding of the energy and the comfort is, of course, important. I really understand that. Yeah. It's important to become the comfortable life and the energy saving for the architecture, the designing. In this slide, I introduced the concept ZEB, stand for the zero energy building. ZEB has become recognized to be important for the energy, the conservation, and the global warming prevention. Of course, the zero energy is very the excitement word, but it's not possible, of course. So what the zero energy building means is net zero energy building. So at the heart of the ZEB concept is the idea that the building can meet all their energy requirement from low cost, locally available and non-polluting and renewable sources. At the strict level, the ZEP generate enough renewable energy on site to equal to exceed its annual energy use in the building. So next, we give some information regarding comfort in a building. Comfort can be defined as the state of the physical, the ease and the relaxation and the freedom from the district. And the comfort in building is affected by the great number of the different factors, of course, and such as the thermal and the air quality and the noise level and the visual comfort. In some cases, even a personal factor can affect our comfort. So anyway, it's important to understand the comfort, the relationship to human, and the control and the limit based on the nature of the physical environment, the physics of the environment. So normally, the term comfort express the satisfaction with the environment based on the ISO standard. However, in my opinion, the thermal comfort is more than just the pleasant condition because it's part of some action subconsciously or consciously executed to maintain the core temperature within a very narrow range around 37 degrees Celsius. Normally, in the AC controller has only the temperature setting. So many people think that associated with the thermal comfort are directly associated with the temperature, but this is not the whole truth. The graph here illustrate the relationship between the thermal comfort and the thermal sensation. The neutral, the thermal sensation is considered as the means of the thermal comfort. So the neutral states UPS comfort. This is because there is no physical temperature regulatory effect as the condition. So this comfort the increase, while thermal sensation for both heat, the hot, and heat loss, the cold, increase rapidly each side of the neutral. In 1970, the famous fungus, highlight the condition necessary for the thermal comfort, as well as the principle and the method for the evaluating and analyze the thermal environment. This is called the fungus, the comfort equation. The most important variable is not just the temperature that affects the thermal comfort as the temperature, the humidity, and radiation here, and air movement, and the metabolic rate, the activity level of the occupant, and the insulation of the clothing. So please remember that there is the seventh parameter that is also important the human mind, such as the individual the expectation and acceptance is also the seventh parameter. As for the quantifying both energy and comfort in a building, the calculating thermal load is useful. The thermal load is the amount of energy the physical unit added to or the removed from. Since the energy from HVAC system uses the dominant, as I told you previously, so the energy can be evaluated by the air condition to thermal load. For the thermal comfort, the thermal state of human can be evaluated by using the human's thermal load. For both cases, it's preferable that the neutral, the thermal load. The thermal load should be smaller so that the change in the internal condition should be within a narrow range. This is one of the concepts for my research. So one of the main functions of the building. So now I like to talk to you about the relation between the comfort and the building. So one of the main functions of the building, the envelope, is act as the barrier, the filter between the external and the internal environment. The net heat exchange between them and the steady state condition, the delta Q, is calculated using this equation. This delta Q is the conditioning thermal load. The estimation of each term is discussed here. The concept and the fundamental of the conditioner is based on the heat gain and or the heat losses, namely delta Q in a building. Sorry. So you will need to remove the amount of heat gain if it is hot outside, and similarly, you'll need to add the heat from your space if outside temperature is cold. This is the air conditioning thermal load. In short, the heat gain, any heat gain and any heat loss must be equally balanced by heat removal and heat addition to get the desired room comfort that we want. So normally, the thermal load calculation are carried out assuming the steady state condition. The space heat gain is the heat which enter into and is generated within a space in a given space, and the heat space loss is the heat, which losses from the space. So the heat gain and losses consist mainly of the following: the transmission of the heat across the building fabrics element, and the heat loss caused by the gain of the loss from the ventilation, and the internal gain, and also the solar heat gain. The heat transmission of the floor, exterior wall, the ceiling, a window, and the doors can be calculated using this equation. The heat loss and gain caused by the ventilation can be calculated by using the middle equation depending on the capacity of heat of the air, and the solar load on the building are calculated the lower equation. The internal the load will vary depending on the usage of the space, so I cannot show here. Sorry, some figure is written in the Japanese, but this is quite interesting figure. This figure shows the heat path between the indoor and the outdoor. This the upper side is the winter station, the bottom side is the summer station. About the 52% of the heat or the energy is lost from the window in the winter station, because the window is the weakest point against the heat. This is a summer station. Again, the window, through the window, the heat is gained. About 70% of the heat gain is from the window. It's quite interesting. So of course, the heat, the insulation of course play an important role in making a building and the energy efficient by keeping warm inside during the winter. However, the same the property can lead to excessive high temperature in the summer. Sometimes the insulation absorbs a lot of energy and release after that. So especially when the design is not adequate to consider solar heat gain. So normally we have a standard for the U value, and additionally the shading the coefficient of the some performance of the solar radiation is added for the standard for the energy saving. This is one of the examples for the energy efficiency standard in Japan. Since the fact suggests that the importance of the reducing the energy consumption for the heating in winter season, as I showed you previously, the heating energy is much larger than compared to the cooling. So we discussed the winter energy reduction. So Japan is stated in a temperate zone, and with the simple wooden building is a major architecture form. So the idea of having warm house and the energy efficient building never occurred to the mainstream until the 1970s. And since the start of the rapid economic growth in Japan during the 1960s, before my birth, of course, the Japanese industry began to promote the popularity of the air conditioning at the time. Since the establishment of the Energy Conservation Act of the 1979, the building standards and energy conservation as standards have been revised substantially in the form of the thermal environmental performance of the building. In an attempt to catch up with those appropriate to the Europe and the US subarctic zone residential building, regulation for the energy efficient building covered by the Energy Conservation Act became totally mandatory in 2017. the construction will not be permitted unless certain kind of conformity are demonstrated in the Japanese situation. Okay, so in order to assess the thermal comfort, considering the energy balance of human is useful. The human body constantly produce the heat energy from having the food, and the heat need to be released at the proper rate to keep the body at a constant temperature level around 37 degrees Celsius. And any heat gain or the heat loss from the thermally neutral state is experienced as a hot or cold sensation of discomfort. So the transport of the heat from the body, human body, is mainly the of the convection, the radiation, and evaporation, the physics of heat transfer. You can see this graph. This graph is based on the subjective experiments conducted in Japan. You can see the relationship between the human thermal load, the energy balance, and the human thermal sensation board, the subjective perception. You can see the good relationship between them. So if I can calculate the human thermal load, we can estimate the thermal sensation, namely the thermal comfort. And actually, it depends on the situation, but under the certain condition, we successfully quantify the thermal environment, the thermal perception by using the human thermal load, so that we can apply this kind of knowledge to the analysis of the present state and apply this kind of knowledge to the environmental designing, the urban designing. And by using analysis like a CFD, we can conduct the prior assessment before conducting something. So this kind of calculation, thermal load, is very useful too. We can utilize by the measurement, and we can utilize by the analysis too, like a CFD for designing. Okay, so now we are applying our quantification method based on energy flow. The visualization of the environment, we can quantify the thermals and the human comfort for the human environment to various fields in the industry. Of course, I have many collaboration study of the research with the industry. This kind of the methodology is very unique to the method for the quantifying the comfort, very unique, I think. So the example of our the work is the monitoring system for the elderly and also some workers outside. And this is for the hazard map, the climatic map for the Osaka area, conducted in my doctor's era. And so the energy and health and the product design, risk management, the building, the design, and so on. Okay, so you can see in this slide about our going project from the small scale, like fabrication of the material, like a clothing material or the building material, and to the large scale, like our urban component, so the urban planning itself. Okay, I can show you some example from the next slide. This slide shows a project for the modification of the urban surface for the UHI, the urban heat island adaptation, and also the evaluation method for the comprehensive evaluation method for the thermal, noise, and also visual comfort. So we are like to try to the fundamental understanding of the combined effect of the thermal and the other components, such as the noise and for the pedestrian. For the urban planning, this is noise simulation. We have the tool for the noise also. Normally, there are so many the laboratory has the tool for the CFD, but we also conduct the simulation for the noise transmission. And we are focusing mainly on material modification, and we also conduct the on-site measurements through the year using a test material, and we evaluate for the human, the perception. This is for the payment material and the building material and so on. Okay. So this is also the project for the building envelope. Our special knowledge is for the water retaining material, the global warming, the amortization, the urban heat island, the increase in, based on that, the increase in air conditioning energy, the consumption-related illness, and the extreme weather trends in natural ecosystem. So we'd like to install some special material in the urban space on the building facade and so on to reduce the energy and increase the comfort around the building and the built environment. So maybe time is limited, so I cannot introduce any detail. So this is the project for the public and the energy and the response to the climate. We are mainly this project mainly focused on the effect of the insulation and the shading and the HVAC system on the environment and the energy use. We are now conducting a field measurement in Japanese the high performance house for the specific construction sites. And we can utilize the CFD analysis for the details, the situation analysis. And sometimes we utilize the Energy Plus or some software for the energy simulation. And of course, we are conducting experiments on site, utilize the knowledge to the simulation too. Actually, there are so many parameters for the building design. So I think the systematic methodology for the building design is required. So we are trying to develop the systematic methodology for the specific the building. So I like to ask you to work with me or with us for the Indonesian situation. The situation is quite different, the material difference, the climate difference, and the preference, the perception with the difference. So it's quite interesting for me. If you have any interested, please ask me. Yeah. And this is also one of the unique the trial of our laboratory. We are trying to utilize the knowledge to the individual adjustment. Actually, we are working with the clothing industry. So this is because we have some tool to quantitatively understand and design the clothing, the ventilation. And I think that the clothing, the industry is very analog, so not a digital. So we like to introduce them to the digital tool based on physics. This is one of the way to design a good product. And also we can also take on the energy saving and the comfort in the building, because we are always wearing the clothing. And in the Japanese the adaptation, the clothing is one of the adaptation for the cooling and for the heating. So the temperature setting is set to the 28 during the summer and the 20 for the winter season. This is we can adjust the environment quickly and depending on the personal preference for using and the clothing adjustment. Actually, we are really I have some very special technique to quantify inside the flow and the ventilation inside the clothing, the interaction between the human, the clothing, and the environment. This is why I conduct the experiment and the research about the clothing is this is based on the actual standard comfort zone. If we change the clothing, the feeling temperature can be changed by the 5 degrees Celsius. It's quite different. So in the tropical climate country like Indonesia, maybe if you can use nice cooler clothing, the cooling summer load can be reduced by the modification of the clothing, application of the clothing. Yes, of course, the principle of the environmental science of physics in the building are fundamentally the same all over the world. They are the same between Japan, Indonesia, US, European country. The physics are the same. But the different country and the region express their requirement in a variety of ways, the energy, the performance, preference. So the local or the traditional adaptation is of course applied. Because this is the climatic graph for Tokyo in Japan and Jakarta in Indonesia. The temperature in Tokyo and the coolest months, the temperature the average temperature will be about 4 to 5 degrees Celsius, and then on the other hand, the summer season, the temperature will be up to about 30 degrees Celsius. In the Jakarta, the yearly about 25 to 30. The climate is quite different, so the local adaptation is of course applied. So we are some project in South Asian country. We are now conducting the experiments in Indonesia, like Jakarta, the Bandung, Pekanbaru, and with some partner university. I have conducting a measurement in Malaysia. I often fly to the Indonesia and the Malaysia. So please join collaborative research. Yeah. The future, why I come to the Indonesia or the some the South Asian countries. So because the purpose of the research for me is the comparison of the residential environment and the energy usage among the city in different climate. Interested in not only the architect but also way of living. This is one of the understanding the way of living is one of the solution for the reducing the energy. So the first step is to understand the station. We compare the thermal preference between them. Maybe your preference will be different from me. Actually, in Japan, we experience the cold winter and the hot summer, but in Indonesian people normally get accustomed to the the hot climate. So this is one of the key or the hint for reducing the energy by the keeping the temperature are relatively higher compared to the Japan. And then first, finally, we like to introduce some technology, and we like to teach the philosophy of the building science. This is the last page for my lectures. The building has a significant impact on the energy and of course the well-being. And the building design normally made to order the custom made, and it's important to have the right technology in the right place and the right time. Not just the technology, but also the combination of the many factors, depending on the situation, responsible for the better built environment of the architecture. Today, one of the frameworks for the healthy and the sustainable built environment introduced based on the energy balance, the heat transfer equation of the human and the building. Thank you for the attention.
Thank you very much, Sensei. Wow. Yeah, 45 minutes and you finish on time. Amazing. Okay, thank you very much, Sensei, for your presentation and also the highlighting the topics, and I think it's a very specific, so many participant can study or learn about your previous research and your project. So before we continue this event, so can we Shashin, like take a picture? So because maybe we can conduct like to participant to open cam and take picture. After that, we can take question and answer, Sensei. Okay. So please, Miss Melissa or Mr. Aldo can provide the take picture together. Okay, everyone can open your camera and we can take picture together. Okay, ready all, and 3, 2, 1, smile. And then another slide. Okay, 3, 2, 1, smile. Okay, next. 3, 2, 1, smile. Okay, thank you very much for the last slide. Okay, 3, 2, 1, smile. Okay, enough. Thank you very much for all the participants that open the camera. Now we continue with the next agenda. Please, if you have any question to Dr. Shimazaki. And also before start, I will to say hello to Tajima Sensei.
Hi.
Konnichiwa.
Konnichiwa.
Konnichiwa. Thank you for coming in this event. Okay, so we have one question from the chat box, Sensei. So in Indonesia, that I know, topic about the green building is a hot issue. For the example, the new capital city in Indonesia, Sensei, in Borneo Islands or Kalimantan Islands. So the government will build several buildings with the concept low carbon energy. In your opinion, is there any correlation between the building with the low carbon energy and human comfort and energy use in that building, Sensei?
It's quite different question for me that because actually I don't understand the situation in the new capital. So if I go and have some the measurement on the climate, for calculating summer load, the precise database for the climate is of course a requirement, and then we are trying to find out the perception of the Indonesian people. Actually, I accept one student from Indonesia for the doctoral study this year, and she is going to find out the new the summer comfort index in your country. At the relationship between them, so we can apply the knowledge to the new building standard.
Okay, thank you very much. So, yeah, for Miss Nava, so we have to explore more about the situation. So if you have the continuous question, you can open mic. If you're not satisfied or you have more question, you can open mic.
Yeah.
So
what kind of go ahead.
Okay, so the next question from Andi Taufan. Thank you, Sensei, for your informative presentation. I have some question. It is not one question. I simulated the scenario using building energy simulation software. So I got max 5% improvement of energy use from one of affordable proposed scenario. I little bit unconfident with the results. In your opinion, is 5% significant enough in the energy saving point of view? This is the first question, Sensei. So Andi Tovan, can you open mic and say hello to the Shimazaki Sensei maybe?
Hello, Sensei.
Hi,
Yes,
Oh,
basically I
okay.
use a design builder
Mm.
and I try to simulate some scenarios such as ventilation
Yes.
scenarios because it is more affordable. Instead, we use, for example, as you explained, something like changing the materials of the building, and that's why I try to propose some ventilation scenarios. But as my question, I only for now I only got 5% improvement on energy use per year, basically.
So you like to install the natural ventilation, is that correct?
Yes, yes. I use a design builder.
Yes, I know the software. So
Yeah.
you conduct estimation by changing the rate of the ventilation, is that correct?
Yes, yes.
So the changing in the energy, the improvement energy is only 5%.
Yes.
Actually, it depends on the situation. I cannot say the exact answer, but as I show you in this lecture, the calculation of the air conditioning load, please check which term has the impact on the overall energy use in a building. If the thermal transmission has an impact on the energy, the ventilation has a less effect, I think. If
Yeah.
the solar gain has a strong effect, you need to use some shading devices or cut the energy from the sun. So that's why the quantification is very important.
Yeah.
Is that okay for that?
Yes, yes. Basically, what I emphasize here is 5% significant enough in the energy savings point of view. Because if we read simulation regarding the passive cooling, they may have about 30%, 20% energy improvement by using advanced materials, for
Yeah, of
example.
course, it depends on the climatic condition, I think. In your country, the temperature difference is quite smaller, so the
Yes.
effect of the ventilation is not big. The ventilation sometimes not have the impact on the house. Otherwise, if the strong wind is required, this causes another the discomfort of the draft, I think.
Okay.
Thank you, Sensei.
Thank you.
I think I get your point.
Yeah. Thank you, Mr. Andi Taufan. Do you want to continue with the second question? So he said
Yeah.
that in Indonesia, people tolerate higher temperature than the standard, but our adaptation behavior is to set low temperature on AC. Because you said, I agree with you. We usually set at the 16, 17, 18. But
Yes, yes.
in my
Sure.
opinion, the AC will not reach that temperature. It's hard.
Are you feel comfortable for such a lower temperature?
Basically, yeah.
Yes.
No, no. That's why my point is in the again in your opinion, like basically I think in Indonesia, we tolerate higher temperature. For example, in S-ray standard, the maximum acceptable temperature limit is 20, maybe 26, maybe. But yeah, but in Indonesia, I think we tolerate up to 28 or 29, maybe 30 we tolerate. But when we set the AC temperature, we always overcool the temperature. We always my point is there any theory behind this, or this is only our mistake on how to our perspective or regarding the temperature, or this is only I mean only local human expectation?
Yeah, very good question. Yeah, I agree with you. Actually, and the summer campus study is developed in US, Europe, and Japan. We have a lot of study previously, and I think that in your country, many of the standard is imported from such country, the developed countries. So you have to modify for your country. So you need to adapt that you need to develop the similar equation from the experiments. It's very important. So I'm really interested in.
So is it based on subjective parameters such as
I think that firstly the subjective parameter is important.
seven fingers?
The physical environment is the calculation can be easy, but the difference for the comfort mean is based on the perception of the people. It may be based on the tradition or the culture sometimes. Yeah.
Thank you, Sensei.
Okay, thank you very much. Nice question that relate with the Indonesia, Sensei. So that's why I talked to my college here. Maybe Sensei, we can ask to the Sensei the opinion about the building in Indonesia.
Yeah.
Because sometimes I agree with you that architecture maybe only talk about not only talk about the design. So maybe we expand it or extend it into aspect environment and also the energy aspect also. Okay.
And you need to install the proper size of the air conditioning system for the room.
Yeah.
A way to reduce the energy.
Okay. Maybe we can thinking in this department.
The capacity.
Yeah. Okay. Next question, Sensei, from the Rizky. Which one should we emphasize, the health aspect or the preference aspect in the energy building modeling? Because the person's preference may be not healthy at all. I'm not clear about the question. So Rizky, can you explain about your question? The mic does not work. So is it clear, Sensei, the question?
Sorry?
So this question is about which one we have the priority for the health aspect or the preference aspect, Sensei.
Which? Sorry.
Yes, if we compare about the health aspect or the preference aspect, so subjective in the energy building modeling, Sensei.
ヘルスじゃないですかね。Health has a priority, I think. Yeah.
Health is priority.
But of course, the expression is depend on the person, so it's quite different to answer. I don't understand well about the meaning of the question.
So I think if my opinion from this question, if sometimes in this building we have two different people. The first people is very sensitive with the cool situation. So I think it's related with the health aspect. So some people it's maybe have the different opinion about the temperature or the environmental aspect. So which one that we have to priority?
Of course, health aspect has a priority. Yes. Then,
Okay, I think it's
for
clear.
the environment. Yes. So I say, I don't say the endure the environment. Yes. The health, the comfort are the priority. Then the minimize the energy use or the impact on the natural environment.
Okay, thank you, Sensei. So this is my question. I have the question from the WhatsApp application. Yeah. So from your topic area, you said that ergonomics is also your expertise. So I have question, what the impact does the thermal comfort have on the productivity and well-being in ergonomic studies?
Yes, the comfort can be lead to the productivity.
So what do you think maybe specific about the like the cognitive or the physical performance?
I understand the question, the meaning of the question. Yeah, of course, the different level require for the different the building, the types of the building. For the cognitive performance, maybe the lower temperature or the highest standard required for the working environment is more the loose standard is enough. So your student come to my lab to measure the working environment. Yeah.
Yeah. Yes, I say.
To the factory building to measure and the human and also the physical environment.
Okay. So today also Ian and Chandra join this event. So Ian or Chandra, you can say hello to the Shimazaki Sensei and say thank you for this lecture.
Thank you for the lecture.
Safe trip. Yeah.
Yeah. Okay. Any question from the participants? And also maybe the head of the study program of the master degree in the industrial engineering is join in this participant, the Professor Arfan Bahtiar. Maybe Prof. Arfan will say hello to you also.
Hello.
Hi, hello.
Dr. Yasudiro Shimasaki.
Hi.
How are you today? Fine.
So he asked about your today. How's your today? How are you? Okay. Thank you, Professor Arfan. So I think we still have around 3 minutes, Sensei. Maybe any one question for the last question for this event? Anyone?
Actually, are you familiar with the subject, the building science or the architecture?
Yeah, maybe when we talk about the like heat and also when related to your human, so we're familiar about that because in the ergonomics we in the first lecture. So for the first lecture in ergonomics, we talk about the environmental aspect and also the effect on the human. So that's why.
Okay. So do you have any concept for of the Comfort? Do you teach a Comfort?
Yeah, for the comfort, I think not yet, Sensei. We just said about the limitation of the human. Yes. So we have the standard in the Indonesian standard and also the international standard. That parameter that we use to design about the product and also the room or the building, something
This
like
is
that.
on the minimum requirement.
Yes, Sensei. That's right.
Mm.
So that's why when you talk about the load in the human, so we can or we know or we understand about the aspect. For the first, maybe in the architecture or the in the building introduction, I think this is new for me for us in the industrial engineering. So one question, Sensei, from me.
Yes, of course.
I think I'm curious. So what the future trends, Sensei, for the intersection about the thermal comfort, energy efficiency, and also the human performance? As we know that many buildings that built by a model of or the trend. So that's why we usually confuse why some people or designer to design this building only by the trend of or the era or that century or the years, that nothing about the how the people inside the building to do the work, study, or just for the living.
なるほど。So what do you like to know?
Yeah, the trend, Sensei. The future. Yeah.
Future. In Indonesia?
Yeah, maybe Indonesia or in Japan, it's okay.
Actually, I hear that the more and more construction companies want to have the human resource to understand the comfort or the energy. Some industry asked me to introduce the good student for that. And if the understanding of the comfort of the energy is increased, the society will be changed. This is a good future for me. Yeah.
Okay.
I can't say that just one direction, but
Yeah, Sensei. So in your opinion,
yeah,
how much the percentage of the art in the building, if compared with the like the energy or like to keep the people inside the building have the high performance, let's say.
What percentage of people?
Yeah, because if we design the building, sometimes people think about the art, the design, the shape, something
Okay.
like that.
Okay. For me,
Yeah.
the energy and the comfort is about 90 to 80%.
Okay.
I don't mind the shapes. And the structure is, of course, important. Yeah, strongly. Building should be strong enough. But for the design, I don't mind.
Okay, thank you very much. Okay, that is the close question. So the times is also enough. So okay, for the next agenda, so I will like wrap up the today's session. So from the presentation, we can conclude that maybe talk about the energy is very important now, as we know that the Earth is increased the temperatures 1 degree, around 1 degree for each year. So that's why we think it deeply. So some research is needed to keep we comfort or feel comfort to keep our the performance also. So Sensei, I want to extend our the deepest gratitude to you. Thank you for the sharing your expertise and also your previous project or the research. Also for the participant for to question and also active to join this event. So I think before we close, maybe I want to back to the MC or to what the name presenter or something like that. Sorry. Okay. Thank you very much,
Thank
Sensei.
you.
So I back to the Miss Melissa.
Okay, I would like to say thank you once again to Dr. Yasuhiro Shimazaki for speaking at today's international guest lecture and Dr. Wiwi Budiawan for moderating today's event. Ladies and gentlemen, we have reached the end of this event. Hopefully, this international guest lecture event with the topic of quantifying comfort and energy can bring us wisdom and benefits. Before closing the event, I, Melissa Haristi, the host of the international guest lecture, would like to say thank you and apologize for any unpleasant words. I look forward to seeing you in the next international guest lecture. See you in the next international guest lecture event. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much, Sensei.
Thank you.